Hi, I'm Bill Ritchie. I'm a printmaker, and I make copper plate etchings like this copy of a Rembrandt etching, prints out like this, or my own plate that goes into a print that looks like this. But some time back, I started making etching presses, and I began decorating them with badges. And I'm going to show you in the next few minutes how I make those badges.
I like to use Adobe Illustrator to create the design, and I reflect it left for right so it reads wrong. For my silicone-coated paper, I could use this circuit board thermal paper. I more often use the shipping label stock from Avery. I tear off the shipping label and throw that away. Now I have a sheet of silicone-coated paper, and that's the side I'll print on. It's a shiny side. My printer is an HP laser printer, black and white only, and is set for its heaviest tone. I'll trim that down for a kind of book, make a little kind of a book, and the plate will be inserted in this little booklet. The second step is to cut and deburr the metal. I choose brass, 25 thousandths thick, and I use a shear from Northern Tools. The brass came from KS Precision Metals. With a felt tip marker, I marked out the size 2.5 inches by 3.5 inches. Cutting leaves a burr along the edge. I don't like that burr because I'm going to be running the plate through a laminator in a later step, so I remove the burr with a flat, mill-cut bastard file. The third step is to tone and degrease the metal. Use very fine 000 steel wool. The tone will help the laser toner stick later on. Use soy sauce to degrease the metal. Soy sauce has enough acetic acid and salt in it to remove any traces of grease, fingerprints, or other residue from the metal. Finally, rinse the metal of all soy sauce. Otherwise, the soy sauce will prevent the laser toner from sticking to the metal. Speed up the drying with a hair dryer or a heat gun. In the fourth step, an office laminator set to its highest temperature can be used to transfer the laser toner from the silicone-coated paper to the degreased metal plate. It takes several passes through the laminator to get the metal hot enough for a good bond between the laser toner and the metal. The video is speeded up. When it's cool, the silicone-coated paper can be peeled back and discarded. In the fifth step, fuse the toner to the metal with either a toaster oven or a hot plate turned on its highest temperature. Hold the metal plate about 1/4 inch above the coil. Move it constantly. Don't allow the plate to touch the coil or it will heat too much in one spot. It takes about 1 minute to 2 minutes to get the effect of a dull gloss finish compared to the original eggshell-like finish. After up to 2 minutes, a little smoke might appear, and then it's time to take it off the burner and cool it. Study the image for flaws that can be touched up in the next step. Fused laser toner is an acid resist. Asphaltum and rosin are also acid resists. In the 6th step, I use liquid universal etching ground as a stop out. You can also use alcohol rosin-based stop out. To conserve my acid mordant, which is ferric chloride, I stop out areas I don't want to waste etching. In an earlier stage, I detected a flaw. It can be traced back to a spot of laser toner which didn't fuse to the metal, and that spot has to be stopped out too with a fine-tip brush. Having used asphaltum for a stop out, I clean my brush with naphtha. If I had used rosin-based stop out, I'd use alcohol. The 7th step is to etch the design in the metal with ferric chloride. I use shipping tape to protect the back of the plate from being etched. Ferric chloride requires that you etch the plate upside down or standing on its edge. I use a long piece of shipping tape with the ends tucked over so it won't stick to my fingers. This long piece of shipping tape lets me suspend the metal plate upside down in the etching tray. Then I can pour in ferric chloride and let it etch, this time about 20 minutes. The 8th step is to add aquatint for texture. Pour off all the ferric chloride and rinse the plate several times with water. Blot the plate dry, speed the drying with a hairdryer or a heat gun, and with a photographer's loupe, check the depth of the etch. Remove the plastic backing and shake up the aquatint box, which contains rosin dust. Hold the plate in the box for about 5 seconds. This will give about 50% coverage. The rosin has to be fused to the plate. To melt the rosin dust, use a hot plate and hold the plate about 1/4 inch over the coils for 45 seconds to a minute until the rosin is fused. In the 9th step, I etch the plate a second time for the aquatint. I protect the back with plastic shipping tape, suspend the plate in the etching tray, immerse it in ferric chloride for about 20 minutes. Then I pour off the ferric chloride, rinse the plate in plenty of water, and then with a photographer's loupe and a raking light, I can see the texture left by the dots of rosin. I clean the plate with lacquer thinner under lots of ventilation for safety and remove all the laser toner and stop outs, and I buff the plate on a buffing wheel. Now I can mark it, ready for cutting it apart to make the badges. The 10th step is to cut the badges, separating them from the plate. Using the shear, I can even trim off some of the corners. Then I'll switch to a hand shear or tin snip and trim the brass down close to the edge of the design. I'll continue with the grinder, round it off. With a file, I'll bring it down even more until it exactly fits the inset it's designed for. The last step is to work a little bit of etching ink into the aquatinted details and thus bring out the design most clearly. Now it's ready to mount into the parts of the Halfwood press.